Hi, this is Scott Allen from Allen Associates. Welcome to the presentation on process safety for the Ginposium. Sorry I can't be there in person, obviously. Things with the pandemic, obviously having to do this remotely. So I'm just going to really chat through the presentation and give guidance to the slides rather than give a normal sort of presentation. You can obviously see on the screen the various elements, but I'll just chat through it. So first of all, just a little bit about Allen Associates. There's our key clients, some of our clients are distilling, and which include the major international drinks companies, and also we do work for significant amount of craft distillers too. A couple of recent projects are in the Ho Distillery in Islay, and it's Holyrood Distillery in Edinburgh. And Holyrood also included a small gin still. So just the contents we're chatting about today: process safety compliance. So we're looking at why do we bother, what is it, legal requirements, key tools for demonstrating risks of a LARP, and some closing remarks. So why do we bother? And often we hear is this doesn't really affect my distillery. Maybe we think it's too small, etc. But the reality is that it does affect every distillery handling flammable material, i.e. alcohol. And you can't really be ignorant of the risks. It's not an excuse. Other things as well, legislation is for the big distillers, it's not relevant to us. That's really is a popular misconception, and it goes right back to the 1974 Health and Safety at Work Act in the UK, where you are, as every employer, is to provide a safe place to work. So it affects everyone, and it can cost too much money. Yeah, it can cost money, but it can also save money. I've not time for safety. I just want to go on and do my project. Yeah, true, but it can actually save time as well. You can, if you get design done up front and do it correctly, it can save a lot of installation time. It'll never happen to me. Yeah, we all think that a lot of things in life, but unfortunately it does happen. And there's some slides coming up which will show you that. What's the worst that can happen anyway? Business can be destroyed, and you could end up, end up in jail. It's pretty horrific, the consequences when you have a potential catastrophic event. So here's some photographs just of some things, distilleries that have had incidents, so you can see obviously these things happen, and yeah, the final one showing that your distillery obviously can be destroyed. So what is process safety? It's a blend of engineering, design and management techniques, solutions to minimise the risk associated with producing and handling hazardous material. These can include risks to people, the environment, and obviously major cost to significant loss as well. In craft distilling, or in distilling, the key industry risks, you've got explosion from vapour detonation, if you've got a vapour release, explosion from levy, from fire engulfment of vessels. You've also, if you're handling cereals, you've got dust cloud detonation. You get risk from fire, from pool fires, flash fires. We're dealing with, materials with low flash points, particularly in craft distilling when you're dealing with GNS, 96% alcohol, which has got a flash point of 13 degrees centigrade, so it's highly flammable. We've also got toxic or harmful releases. We've got release of carbon dioxide in fermentation, and also cleaning chemicals. But this presentation is really focusing on the fire and explosion risk. So looking at legal requirements, we really have to look at demonstrating the risks are a LARP, which is as low as reasonably practical. To do this, as well as designing to relevant standards and guidance, then the following would be expected to demonstrate risks are a LARP. We're looking at having a full set of P&IDs, ATEX Nazir documentation complete, risk assessment done, for example, HAZOPs, still determination done using, you can use the layer protection analysis. In our experience, there's a lack of these in craft distilling. So just looking at P&IDs first, it's a diagram which we use a lot in process design. It's the fundamental part of the design, and it forms part of the process safety. It really is a building process as a design develops. And I'll just show you an example here as a P&ID goes through the design process. So you're starting off a pretty basic process flow diagram showing this one is showing the transfer of spirit from a tanker into a vat and then into another vat for preparation for bottling. As we then add in more detail, we're now showing more instrumentation, valving, etc. And then we go through and we're starting to show tags on the individual items. And then finally we can start to show control and safety loops. So that's how a P&ID process develops. Ideally, yeah, everyone should have a set of P&IDs for their site. Moving on to the DSIR and ATEX regulations, which essentially deals with hazardous area classification and then the risk assessment for fire and explosion of the area. In the UK, the regulations are the DSIR regulations, which is the UK regulation to implement the EU Atmosphere Explosives Directive, ATEX. Throughout the world, actually, we follow a very similar regulation, and there are some other regulations on the list which can be relevant and useful, good guidance for ATEX compliance. So a typical review scope would be, first of all, you identify the flammable or the dangerous substances on site or in the process. Identify sources of release that may generate a flammable atmosphere. Determine the zone classification. Risk assess the site, the system, etc. Implement measures to minimise the risk of release. Then you control and manage ignition sources in the hazardous area, ensuring all your equipment, etc. is ATEX. And then you can develop and display the hazardous area classification drawings, which show the zones on the plant layout drawings. Here's an example of a little gin system, which has been zoned. This is the elevation drawing. The regulations changed a few years ago where you have to do elevation drawings as well as plan hazardous area drawings. So looking at the zoning itself, zone 0 is where a gas or vapour is present continuously, frequently. Zone 1, if it's present occasionally, intermittently, and then zone 2 is during abnormal operations. It's rare that you have it, and it's zone 20, 21 and 22 are for dusts. So just looking at a wee example here of DSIR or ATEX not being considered in the design process, and here we have a little stillhouse area next to some fermenters, and at the moment we're assuming that there's no containment and nothing is vented outside, which we do see this, and which is giving us a zone 1 area, which really is unworkable. And in fact, operators should not be in that area. If we move on and see what we can do to improve this, now we should be able to get a situation where we've actually got, it's mainly zone 2, that whole fermentation area is actually safe, and you've only got small pockets of zone 1 areas. So how do we do that? Well, in the risk assessment, you would assess where the releases are and what they're doing. So in this case, it's relatively straightforward. Vent everything outside from your stills and your receivers. Now put in containment, so any spills in the stillhouse cannot go in to the turn room or the fermentation area. And that then gives you the ideal zoning for that process. So as you can see, looking at the DSIR ATEX regulations, for designing for this, it's vital to consider this at the design stage, because you can make these changes at the very beginning of your design and it affects everything. It affects your process layout, it affects all your drainage and ventilation and your visitor routes as well. So it's something that should really be done alongside the design process rather than being considered at the end of when your distillery is being built. How do we identify further hazards in the process? There could be still remaining issues in this design which we've not picked up through DSIR, and this now takes us on to the HAZOP study, which is a key milestone in the design process, and it interrogates the design in detail. So the HAZOP study is a hazard and operability study, also known as deviation analysis. The aims of the study are to interrogate the design, identify deviations, hazards or operational issues from normal operation. Then you determine the ultimate consequences of those deviations, identify safeguards that prevent or mitigate the consequence, and if there's no safeguards or if required, then you assign actions to reduce the risk to a LARP based on good industry standards and good engineering judgment. So where did the HAZOP come from? Well, it goes back to the 60s and 70s when there was larger accidents with bigger chemical plants, bigger accidents, and the traditional approach of to prevent repetition was no longer acceptable. So a better method was needed to anticipate problems. What causes these accidents? Well, plants are typically designed for flow sheet conditions, i.e. normal conditions. And the key thing about the HAZOP is to identify plant operations, what happens under abnormal conditions, and that's where going back to the deviations. And deviations are various, you look at start-up shutdown conditions, higher flow conditions, higher pressure conditions, higher temperature conditions. And For example, a high level is another one, high level deviation. And if we look at this incident that happened a few years ago, there was where a distillery went on fire. It was associated with a high level issue on a tank, and this is something that may have been picked up if there had been a HAZOP. So if we look at an example here of high level in your ISR, so it's going back to the similar still house before, where you've got the still and you're coming across from the condenser into your safe and then into your ISR. So you look at what could be the cause of high level in that ISR. Well, you could just failure to switch between faints and spirit, or you could have, maybe there was some spirit left in the ISR prior to startup. It wasn't transferred across and it wasn't realised. So the consequences of that, what is the consequences? Consequences if it will overfill, and the worst case is there could be a fire. What's the safeguards that we have in place at the moment? And what we've got is we've got containment, which it keeps the spill contained. But is this enough? Should other be actions required? In this case, we would expect there to be a level switch on the tank to alert the operator of high level. So that's showing you how the HAZOP identifies that by looking at the high level as a deviation. And even then you would be thinking, oh, well, is that enough? Because this still, the switch on ISR still has to have a response from an operator. So you would interrogate it further, and then ultimately you come up with the right solution, which is to have a independent high level switch, shutting off the steam to the still. So in the event of high level in ISR, your steam to the still will shut down, which obviously will stop producing any more spirit coming into the ISR and stop the high level event. This is an example of how the HAZOP process works. So you break your process down into these nodes, which you would describe the previous example as one node, and then you interrogate that node with all the different deviations. And just going back to that example, I'll just leave you with the thought of what would happen in this situation if there was no cooling water flow to your condenser. I appreciate the cooling water is not shown on the drawing, but what would happen, and what's the safeguards, what's the consequences, should there be some other actions in there to prevent that from being an issue. Okay, so going on, you cannot, to the actual HAZOP study itself, you can't HAZOP on your own. It really is it's a team effort, and you need some people in the HAZOP that have got the right experience. You need a chairman, a leader, so it's fully qualified, accredited and independent, a scribe. Ideally, people understand the process, distillery manager, assistant manager, brewer, process designer in this HAZOP, potentially operators, maintenance as well. And if there's a particular piece of manufacturing kit, for example, a whole still package, then the manufacturer's representative should be there as well. So I'm just going to talk a little bit about the LOPA study, layer of protection analysis, which comes after the HAZOP. And this really looks at the scenarios which result in a severe consequence, for example, a fatality, which requires further study to ensure the risks are within tolerable limits. And the LOPA study is preferred by the HSE in the UK. It's a semi-quantitative risk assessment which demonstrates that the risks associated with hazardous operations are managed and are broadly acceptable. The aim of the study is really to determine the overall probability of each high severity event, for example, the high level on the ISR, and then this determines the safety integrity level, SIL, of the safety system. Now, typically in distilling, you might not even have a SIL level, but you could get to SIL 1, very, very occasionally SIL 2. If you look at the nuclear industry, and you're up at SIL 4, just to give you a few. SIL 4 is the maximum SIL level you go to. Let's say you have that in the nuclear industry, but the distilling, sometimes you don't need to go to SIL. It doesn't come out as a SIL level, but it could be SIL 1 and very occasionally SIL 2. And it's really all about making sure the safety system is robust, suitably designed and robust for the appropriate SIL level. And that's what the LOPA study does. Just closing remarks, really, this is all about pulling everyone together and having a real proper health and safety sort of life cycle to form the basis of safety for your plant. You know, all these, looking at your dossier, looking at your PNIDs, managing all the changes, HAZOPing it, doing a LOPA if required, and just managing the process. That's what it's all about, and it's actually it's not as bad as it seems. It's a process which you follow, but it's a very, very important one. There's other, this is obviously just an introduction to process safety. There's other hazards in your process. You're using alcohol in different ways. You've got mentioned before. There's also dust as well. Particularly, obviously, if you're using producing GNS and first principles, you'll have grain dust. You've got steam systems. There's emergency relief systems, and there's other regulations associated with all that. But anyway, hope that's a good introduction for you, and feel free to get in touch with anyone from Allen Associates. If you look online, you can get onto our website. Any questions, etc. Our email addresses are there. Okay, thanks for listening, and take care.